Yes. Hello students, welcome to the session. Welcome to Unacademy Telugu channel. Before going to today, before starting the today concept, please let me introduce myself. Students, my name is Surendra Babu. For 10 years, I am educating the students for GATE, ESE and PSUs in the field of electrical and electronics engineering. Yes, students, these are the subjects I am teaching for electrical students, power electronics, power systems, electrical machines, electrical and electronic measurements. Whatever the core subjects are there for electrical students, all the core subjects I am teaching the students. You please concentrate. And this subject I am teaching for instrumentation students. This one of the core subject for instrumentation, that is the transducers and mechanical instrumentation. Students, apply my promo code BABU10, get the 10% on Unacademy Plus subscription, and also apply my promo code BABU10 to unlock our Unacademy learning app. Yes, students, now come to the Unacademy subscriptions. There is a plus subscription. If you select the plus subscription, these are the benefits we can get the students. Yes, live classes, crash courses, weekly tests, doubt solving sessions, that is available in English and Hindi. Yeah, these are the benefits you can get if you select the plus subscription. Students, come to the iconic subscription. If you select the iconic subscription along with plus subscription, these extra benefits are added, students. These extra benefits. Personal coach is available. Study planner sessions, that is study booster sessions, personalized test analysis, preparatory study material. All these extra benefits are added if you select the iconic subscription, students. Students, you please concentrate. This is a plus subscription, this iconic subscription. This iconic subscription, these extra benefits are added in order to crack any competitive exam. Students, you please concentrate. Sir, how to get our Unacademy learning app, sir? Then search Unacademy learning app in your Play Store. Then second step is install the app, students. This is the second step. Yes, sir, you please concentrate. The step 3 is manage your goals. Now you are in GATE and ESE. Select GATE and ESE. Then select the plus. Get the subscription, students. To unlock your app, apply my promo code BABU10. Students, download the Unacademy app, that is Unacademy learning app. Then unlock that app and use my promo code BABU10. Then whatever the goal you selected, and that so many videos, our top lectures, our Unacademy educators all are already explained, and you also participate in the live classes. You please concentrate. Yes, students, now see the what are the course fee details for plus subscription. For GATE and ESE, both two courses, students, here, not one course. GATE and ESE, two courses. For 12 months program, students, it's a 1 year program. Apply my promo code BABU10. Get the 10% discount. After 10% discount, you pay only 27,225 rupees. These are the two courses, students. GATE and ESE. GATE and ESE. Then whatever the benefits I told already in the plus subscription, all those benefits are added, students. It's a 1 year program, two courses, extra benefits also. You are paying only 27,225 rupees. Yes, this also for plus subscription, students. It's 18 months program. It's a 1 year, 1.5 year program. Apply my promo code BABU10. Get the 10% discount. Then you pay only 34,650 rupees for two courses. GATE and ESE, students. GATE and ESE. And whatever the benefits are there, all those benefits we can get in the case of plus subscription, students. Yes, this also for plus subscription, sir. For GATE and ESE. It's a 24 months program. That is a 2 year program, students. 2 year program. Apply my promo code Babu10. Get the 10% discount and you pay only 39,600 rupees. 39,600 rupees, sir. These are the course fee details for plus subscription, sir. As students, please concentrate. This for GATE and ESE, sir. It's iconic subscription, sir. Already given, it's a large circle. That extra benefits along with plus subscription. If you want that extra benefits also. Yes, sir. Then apply my promo code Babu10. Get the 10% discount and you pay only 45,225 rupees, sir. It's a 2-year program, sir. It's a 24 months program. It's a 2-year program. Apply my promo code Babu10. Get the 10% discount and you pay only 66,600 rupees, sir. These are the course fee details for iconic subscription, sir. It's a 1-year program. This is 1-year program. It is a 2-year program. That is 24 months students. It's a 2-year program. Sir, you please concentrate, sir. This is about course fee details for Unacademy plus subscription and also for iconic subscriptions and also for iconic subscription. Yes, sir. Sir, you please concentrate. This is plus batches taken by our top educators for electrical and ECE, sir. This is for electrical and ECE, sir. You please concentrate. This plus batches taken by our top educators. Target ESE prelims. These are the batches are running. Target ESE prelims 2021. Rank booster batch for GATE 2021. Target ESE prelims for 2021. Rank booster batch for GATE 2021 students. This is for electrical and this is for ECE and this is for electrical. This is for electrical students. These are our top educators who are taking the classes in plus batches. Yes, students, please concentrate. This is our Unacademy GATE Telugu December month schedule and crash course schedule, students. Along with the timings it is given. You please concentrate. Okay. This for total December month schedule. This crash course. In crash course, power electronics, EDC and aptitude is going on. In the December month schedule, this month, these are the subject. These timings also given, students. Communication systems, electrical machines, engineering mathematics, power systems, aptitude students. You please concentrate. Yes. Sir, this is for evolve for GATE 2022, sir. Starts on 21st December, sir. This is both in English and Hindi. For electrical, you please concentrate. Use code EE GATE 10, sir. Then this is for ECE batch, sir. This also starts on 21st December. Apply ECE GATE 10, sir. This is available in English and Hindi, sir. This for GATE 2022 students. 2022. You please concentrate. You ready for starts on 21st December. Yes, sir. This one more. Know your basics, sir, for GATE 2022 and 2023, sir. This is a free special classes series, sir. You please concentrate all the branches, mechanical, civil, electrical, ECE, CS and IT and chemical also, sir. It starts on December 20, sir. It starts on December 20. Students, you please concentrate. It's a free special class series. You ready for to know the basics, sir. For any competitive exam, either GATE, mainly for GATE and ESE, the basics are very important, students. The basics are very important on every subject. In order to get the every subject, fundamentals on every subject, that starts on December 20, students, for GATE 2022 and 2023. You ready to get the basics on each subject, on every subject. Yes. Yes, all of you, good evening. Yes, good evening, sir. All of you, good evening. Yes, we'll start today topic. In the last 2 sessions, I explained about the fault calculations in LG fault and LL fault, sir. Line to ground fault, line to line fault, I explained, sir. Now, today's session, I am going to explain in the unsymmetrical fault analysis itself. That is the double line to ground fault, sir. What the fault calculations in double line to ground fault, sir. Double line to ground fault, LLG fault, sir. Okay. Students, ready? Shall we start today concept? Yes, you please inform to your friends. Then share to your friends, students. Very important analysis I am giving every day. In the last two sessions, I given LG fault, LL fault, sir. Then LLG fault, sir. Next coming sessions, triple L fault and triple LG fault. That is symmetrical fault analysis. I will do, sir. Then next coming sessions, I will give the what is the that is whatever the open faults are there. What how to do the analysis on open single conductor open, two conductors are open faults, sir. Then after that, I will explain different grounding methods also. I will explain, sir. Okay, what is the different grounding methods? Okay, all these concepts I will discuss, sir. You please ready for to get answer. You please share with your friends and inform to your friends, sir. Yes, shall we start? Yes, sir. LLG fault analysis, sir. See, I am following the same procedure, sir. Because I am not deviating. One concept different method, another concept different method. Like that I am not doing, sir. See, every core subject we can listen like this only, sir. Okay, you do by yourself. The concept, similar concept I am following. I am not deviating. Understood, sir? Yes. Now I am explaining the LLG fault analysis. Line to ground fault, sir. Line to ground fault, sir. Double line to ground fault, sir. Okay, sir. First, I want to discuss without any fault impedance, sir. Without any fault impedance. Let this is the A phase voltage, sir. This is the A phase voltage. Yes, students, you please concentrate. This is the A phase voltage, sir. Let the A phase current is IA, sir. Yes. This is the B phase voltage, sir. This B phase voltage is VB, sir. The C phase voltage is VC, sir. Let the B phase current is, this B phase current is IB, sir. And this C phase current is IC, sir. C phase current is IC. Then what is this excitation EMFs of alternator or generator, sir? This is EA or EA1, sir. This is, sorry, you please correct that one, sir. This, I am representing source. Yes, you please, sir. This is plus minus EA, sir. This minus plus EB, sir. This is minus plus EC, sir. Okay. Then it is also equal to EA1, EB1, EC1, sir. That let this grounded through impedance ZN, sir. This neutral is grounded. Neutral is connected to ground, sir. That is a mean. Neutral is connected. Any equipment you can ground, sir. Here neutral is grounding, sir. You don't confuse. This is ZN, sir. Neutral impedance is ZN, sir. Let the neutral current is IN, sir. The neutral current is IN. Yes. Then this is EA, this is EP, this is EC. This is the excitation EMFs. These are the phase voltages VA, VB, VC. This is the terminal voltage, sir. Let assume that there is a line to line and ground, sir. I am assuming that there is a fault at between B and C, and this is the grounded, sir. This is grounded without any ZF, sir. This is between B and C. There is a fault is exist and it is grounded, sir. This fault, this is the grounded. Line to ground fault, sir. Line to ground fault, sir. You please concentrate, students. Yes, sir. Let this is grounded. Yes, sir. This is grounded. Now, this is the fault current, student. This is the fault current. This is the fault current. The fault current is IF. Yes, sir. This is VB and this is VC. And this current is IB and this current is IC. Here I am not considering any ZF, sir. Without ZF. That ZF equal to 0. Yes, clear, students? First I am writing free fault conditions. Free fault. Same procedure, students. You write by your own. You write by your own. Follow like this. Yes, free fault, sir. Before fault. Yes, students. Assume that this alternator is under no load condition. No load condition means there is no current, sir. I am talking about free fault. Still I am not considering this fault, sir. Free fault condition. What is IA equal to, sir? 0. What is IB, sir? IB also 0. What is IC, sir? IC also 0. Because it is a no load, sir. It is a no load condition. Then what is VA, sir? The terminal voltage is nothing but excitation EMF, sir. VA equal to EA, sir. That is equal to, system is under balance condition. It consists of only positive sequence component. Then VB equal to EB, sir. That is equal to EB1, sir. This is equal to EB1. You please concentrate. This is equal to EB1, sir. Then what about this one, sir? VC equal to EC, sir. This is equal to EC1, sir. Yeah, these are the conditions before fault. That is the pre-fault conditions. It is the conditions before fault, sir. That is the pre-fault conditions. Next, during fault, sir. During fault. Students, please concentrate. During fault, sir. That means under fault condition. Which faults are LLG faults, sir? This is also one of the short circuit faults. This is LLG faults. Now, during fault conditions, sir. Fault, I am assuming that between B and C lines, sir. I am assuming that between B and C lines, that is connected to ground, sir. Then if fault is here, but there is no fault here, that's why IA, because still alternator is at no load condition. What is IA, sir? IA equal to 0, sir. But fault is takes place here, that's why VA is also not equal to 0, sir. Students, please concentrate. VA is also not equal to 0. Yes, now see, listen please, all of you, how to write the conditions. Don't by heart, sir. You write by your own. Follow what I am teaching. See, listen, sir. This point is VB point. This point is VC point, sir. But this total is connected to ground, sir. That means this VB point, VC point is at what potential, sir? Ground potential, sir. Yes, sir. This is VB, sir. This is VC, sir. But it is connected to which point, sir? Ground point, sir. Understood or not? This is VB point, sir. And this is VC point, sir. This is connected to which point, sir? Grounded. What is the ground potential, sir? 0. What is this potential also, sir? 0. What is this potential also, sir? 0. Clear, sir? See, in the previous case, in the last session, LL fault, we are not taking 0, sir, because it is not connected to ground, sir. But where we are taking VB equal to VC, sir. But here VB equal, no doubt at all. VB equal to VC equal to 0. Because it is grounded, sir. Ground potential 0. Understand? You please concentrate, sir. Now one more equation. Please, sir, you write by your own. Yes, sir. This is IB current, sir. This is IC current, sir. These two currents are entering. This current is entering here, sir, at this node. This is entering current at this node is IC, sir. Understood? This IB current is enter at this node, sir. IC current also enter at this node, sir. Which is the leaving current, sir? IF, sir. Then apply KCL at this node, sir. IF equal to IB plus IC, sir. Clear, students? Over. These are the during fault condition. IA equal to 0. VA. Once you write the condition, doing the analysis is very easy. VB equal to VC equal to 0, sir. Because it is connected to ground potential, sir. Then IF equal to IB plus IC, sir. IF equal to IB plus IC. It's okay, sir. This is the fault current. That fault current is also equal to grounding, sir. Ground current. It's flowing through the ground. Okay. Any notation you. This is the fault current that is equal to ground current. It's okay, students. VA not equal to 0. That's why under fault condition, system is unbalanced, sir. The system is unbalanced. Clear, students? Is it okay? Please concentrate. System is unbalanced. Now, I want to calculate symmetrical components of voltages. Here itself I am doing symmetrical voltages or symmetrical components. I want to calculate symmetrical components. You calculate voltage and currents separately. That is no problem. Here I am calculating symmetrical component of voltage. Symmetrical component. Mainly I want to require here voltages, sir, to draw the sequence network. That's why I am doing here itself. Sir, what is VA naught, sir? What is VA naught? This VA naught equal to 1 by 3 VA plus VB plus VC, sir. Then what you can get, sir? VA by 3. Why, sir? VB equal to 0, sir. VC also 0, sir. This VB 0, VC 0, you substitute here, sir. What you can get, sir? VA by 3. What is the VA1, sir? Please, students, concentrate. 1 by 3. What is VA1, sir? Here I am writing VA1, sir. Is okay? Yes, sir. 1 by 3. 1 by 3. Yes, sir. VA plus alpha VB plus alpha square VC, sir. This is equal to how much, sir? You substitute VB 0, sir. VC also 0, sir. What you can get? VA by 3. VA by 3. Here I am calculating VA2 students. VA2 sir, VA2. 1 by 3. VA2 sir, 1 by 3. Yes students. VA plus alpha square VB plus alpha VC sir, alpha VC. Substitute alpha sir, VB0 sir. You know already VB0. This is the calculation under fault conditions sir. Symmetrical components are calculated under fault conditions sir for unbalanced system. 1 by 3 VA plus alpha square VB plus alpha VC sir. This how much sir? VA by 3. This also VA by 3. Yes, this observation is important to draw the sequence networks. That means, see, this is very important condition sir. Under LLG fault, for LLG fault condition, VA not equal to, yes sir, VA not equal to VA by 3. VA1 equal to VA by 3. VA2 also VA by 3. All the sequence components of voltages are equal. This is the condition sir. Yes sir. That means for LLG fault, what is the observation sir? VA not equal to VA1 equal to VA2. That is equal to VA by 3. That means VA not equal to VA1 equal to VA2 sir. That equal to which one sir? VA by 3. Okay sir. That means for LLG fault, double line to ground fault, all the sequence voltages are equal. One more observation sir. If you write the with respect to sequence current sir, what is IA sir? IA is 0 sir. You please concentrate students. This IA 0 sir. IA is 0. If IA is 0 sir, what is the condition? We know this in symmetrical components. IA naught plus IA1 plus IA2 is equal to 0. Because IA equal to 0 means IA naught plus IA1 plus IA2 is also 0. These conditions you remember for LLG fault. Now, because of all the sequence voltages are equal, hence sequence networks are connected in parallel. Hence, sequence networks are. These are under fault conditions. All these analysis is under fault conditions. Sequence networks are connected in parallel. Why sir? All the sequence voltages are equal. Now I am connecting all the sequence networks in parallel sir. Sequence networks are connected in parallel. Yes, please concentrate sir. I am connecting under fault conditions. You please concentrate. Yes sir. This is the positive sequence network. You please. This is the positive sequence network. This is connected in parallel sir. How to draw the positive sequence network, you know, along with source we can represent, along with the source, sorry sir, yes, along with source we can represent this plus minus EA sir, this plus minus EA or EA1, actually it's a EA. Our reference is which one sir? Neutral. This our reference is neutral. Yeah, this is the positive sequence networks. This is the positive sequence network. Then you draw the negative sequence network also sir. You draw the negative sequence network also. You please concentrate. Yes sir. Next, you draw the negative. This is which one sir? Z1. This is Z1. I am drawing the negative sequence network. Here also reference is neutral sir. Here also reference is neutral. This is Z2 sir. Next you draw the, because we are connecting in parallel, draw the zero sequence network sir. Draw the zero sequence network. This impedance, that is grounded, neutral is grounded through impedance sir. This neutral is grounded through some impedance. This is how much sir? 3Zn. This is Z0 sir. This is Z0. Okay, you please concentrate. Then this is which one sir? Zero sequence. What is this current sir? IA1. What this current sir? IA2. What this current sir? IA0. Because it is zero sequence. Okay, all these are connected in parallel. You connect in parallels. This is connected in parallel. You connect all these networks in parallel. This is a parallel connection. Very simple, sir. Then what is this voltage, sir? VA1. This voltage is VA. What is this voltage, sir? This is VA2. This voltage is VA2. What is this voltage, sir? VA0. This is equal to VA0. See, in parallel connection, if it is differently given the network, simply remember, sir, similar terminals are joined together. This is similar terminals are joined together. This side similar terminals are joined together. This is our reference is neutral. In any fashion it is given, sir. To make the confusion, the examiner will make differently the connection maybe. But you check is a parallel or series. If similar terminals are joined, sir, this terminal, all these similar terminals, this terminal and this terminal and the similar terminals are joined. This side also similar terminals are joined, sir. Then it is a parallel connection, sir. Like that you feel. But in different textbook they given like this by changing that network. First they given zero sequence, finally it is given positive sequence. Like that it is giving, sir. Whatever may be, parallel means similar terminals are joined or not. That you check the conditions. Clear, sir? Similar terminals are joined or not. Yeah, this is EA1, sir. This is EA1. Okay, EA1. If you want that, this voltage is EA1. All the similar terminals. Now see what is this current, sir? This current is IA1. Students, you please concentrate. What is this current, sir? This is the direction of IA0. What this one, sir? This is IA2. Sir, apply KCL at this node, sir. What you can get? All these currents are entering, sir. If you apply KCL at this node, this condition is satisfied. That is IA1 plus IA2 plus IA0 equal to 0. Yes, your network is correct. Then VA1 equal to VA2 equal to VA0. Yes, your network is correct. Understood, sir? Okay, VA0 equal to VA1 equal to VA2. Okay, this is about the sequence network for which faults are LLG. Sir, here our reference is grounds because it is a zero sequence. Yes, sir. Okay, this is about what exactly? The sequence network for LLG fault under which conditions are fault condition. LLG fault condition. Yes, students, please concentrate. Yes, sir. Now, I want to analyze this network. To analyze this network, you listen please. How to analyze this? Analysis of symmetric, this network, sequence networks, analysis of network. Please concentrate, students. I want to analyze this network. Sir, what is analysis of this network? You please concentrate. Now, this total I am writing as one equivalent circuit, sir. And this is the positive sequence. This voltage is EA1, sir. Plus minus EA1, sir. Yes, students. Next, this is negative sequence. Negative sequence. Instead of here, I will take the next slide, sir. I will take the next slide. Please concentrate. Analysis of network. Please, sorry. The next slide I am taking. Yes. This is analysis of network. That network, whatever the network I draw, that network I am analyzing. These formulas are important to solve the problem. Yes, sir. Here there is a positive sequence. This is a positive sequence network plus minus EA1. This is. Then what is this one, sir? It is the negative sequence. The negative. I am drawing the equivalent circuits. And this is the zero sequence. This is the zero sequence. Now what is this one, sir? Z. What is this one, sir? 3Z. Yes. What this current, sir? This is IA1, sir. What this current, sir? IA2, sir. What this current, sir? IA0, sir. I am analyzing the network, sir. You please concentrate. Whatever the sequence network I given, all these are grounded. Yes, sir. This plus minus. This is IA1. What is this one, sir? Z1. What this one, sir? Z2. Yes. Now tell me, sir, I want to write the expression for IA1. The fundamental students, network theory, fundamentals. Okay, what is this IA1 students? What is this IA1? You want this current, this current. Then EA1 by total voltage in this network is how much students? EA1 by, yes, what the equivalent impedance, sir? Equivalent impedance. See, I want IA1 means total voltage by total impedance. This is Z1 plus Z1 plus, but these two impedances are how it is, parallel student. These two impedances are parallel. That is Z2 in parallel with Z0 plus 3ZN over fundamental students, network theory analysis. Network theory. It's a network analysis. That is Z1 plus Z2 in parallel with Z0 plus 3ZN. The Z2 and Z0 plus 3ZN is how it is. These two students, these two are parallel. These two networks are parallel. Then this is comes in series with Z1. That is Z1 plus Z2 in parallel with Z0 plus 3ZN. This I am not simplifying, leave it. That how to calculate this parallel combination, that Z2 is in parallel with Z0 plus 3ZN. Is clear? Students, is okay. What is the Z0 equivalent here? If you want to write Z0 equivalent, Z0 plus 3ZN. Simply you can write like this, students. This is IA1 equal to EA1 by, please concentrate, Z1 plus Z2 in parallel with Z0 equivalent. Z2 is in parallel with Z0 equivalent. Okay, this is the calculation of IA1, students. Once you know the IA1, sir, I want to find IA2 and IA0, sir. Sir, how to find IA2, sir? Apply the current divider rule, sir. Apply the current divider rule. I want IA2. What are the total currents are? IA1. This IA2. But this IA2 and IA1 is opposite directions, sir. Please, students, concentrate. This IA2 and IA1. This is the direction of IA2. But this is the direction of IA. That means, sir, this IA2 and IA1 is opposite direction. Then how to apply this IA2, sir? How to apply IA2? This is minus IA1. Minus IA1 into opposite impedance. What is the opposite impedance, student? Z0 plus 3ZN. Current divider rule. Z0 plus 3ZN. Why? What are the total impedance are? Z2 plus Z0 plus 3ZN. So, okay. Clear, students? I am calculating IA2 applying current divider rule. Why I taken negative? Because this is entering current here, sir. This is entering current here, sir. This is entering. That's why minus IA1 into Z0 plus 3ZN by Z2 plus Z0 plus 3ZN. Clear, students? IA2. Similarly, you write the formula for IA0, sir. IA0. Please concentrate. I want this current, sir. IA0. This also entering at the node, sir. Then minus total current is how much, sir? Minus IA1. Current divider rule. Opposite impedance, sir. Which is opposite impedance, sir? Z2. By total impedance, sir. Z0 plus 3ZN plus Z2. This impedance plus this impedance, sir. This is IA0, sir. Yes, you calculate. Very important calculations to solve the problems. This is IA2, sir. Yeah, this is IA0, sir. This network I am analyzing, sir. It's a very simple analysis. Like this you calculate. Clear, students? How to calculate IA1, how to calculate IA2, how to calculate IA. If you want, add all these IA0 plus IA1 plus IA2, you can get the 0. If you want, check that one. That condition will satisfy. It's okay, sir. This is IA0, IA1 and IA2. It's very simple. Just we are analyzing the network. You know the network analysis that we are. Students, is it okay? You please concentrate how to calculate. But here I want to calculate the fault current, sir. Main motive is you want to calculate the fault current. Then how to calculate the fault current? I am taking the next slide, students. You please concentrate. Yes, sir. First, you calculate what is the fault currents. What is the fault currents? Yes. For that, I want to calculate ABC currents, sir. ABC currents. Yes. What is IA, sir? I already given. What is IA, sir? IA equal to 0, sir. You know this one, IA equal to 0, sir. What is IB, sir? This IB already you know this one, sir. IB equal to IA0 plus alpha square IA1 plus alpha IA2, sir. What is IC, sir? IC you know this one, sir. IA0 plus alpha IA1 plus alpha square IA2, sir. Please concentrate, everyone. Yes. Now I want to fault current, sir. What is the fault current IF, sir? IB plus IC. IB plus IC. Clear, sir? IB plus IC, sir. Adding these two, sir. Adding these two. If you add these two, 2IA naught, sir. 2IA naught plus take the alpha square is common, sir. Alpha square is common. IA1 plus IA2. Is okay. Take alpha is common, sir. IA1 plus IA2. Yes, sir. IA1 plus IA. Yes. What is IF equal to, sir? 2IA naught. 2IA naught. Plus take IA1 plus IA2 is common, sir. IA1 plus IA2 is common, sir. Yes, students, please concentrate. That is alpha plus alpha square plus alpha. We know this one, sir. 1 plus alpha square equal to 0. Now from this, what is alpha plus alpha square, sir? Minus 1. You substitute there, sir. What is IF equal to? 2IA naught. 2IA naught minus this I am substituting alpha plus alpha square is minus 1, sir. That is IA1 plus I2. Sir, one more observation, students. One more observation. You know this one. IA naught plus IA1 plus IA2 equal to 0, sir. If IA naught plus IA1 plus IA2 equal to 0 means what is IA1 plus IA2, students? Please concentrate. This is equal to minus IA naught, sir. You substitute minus IA naught here, sir. Then what is IF, sir? This IF equal to 2IA naught minus of minus IA naught. How much you can get, sir? 3IA naught. Very, very important formula. This is the fault current in the case of which fault? LLG fault. Please concentrate. This is the calculation of fault current. In LLG fault, the fault current equal 3 times of zero sequence component of currents. 3 times of zero sequence component of current. That is IF equal to 3IA naught. IF equal to 3IA naught. Like this we can calculate. Clear, students? You please consider. What is IA naught, sir? You already calculated that IA naught, sir. This is IA naught. You substitute there, sir. You can get the fault current. Minus IA1 into Z2 by Z0 plus 3Zn plus Z2, sir. This IA0 once you know, you substitute there, sir. Then we can get the what is the fault currents. Yes, students, please concentrate, sir. You please concentrate, sir. Please concentrate. Yes, like this we can calculate the fault currents. Is okay, students? Once fault current is calculated, this I am giving note. If fault current is calculated in per unit, if fault current is calculated in per unit, then how to get actual value of fault current, sir? The actual fault current equal to per unit fault current into base current, sir. Per unit fault current into base current, sir. Then once you know the actual fault current, what the short circuit MVA, sir? The short circuit MVA equal to 3 into VB into actual value of fault currents. Like this you calculate fault MVA. It's very simple calculations. VB is the base voltage, sir. Base voltage you are selecting. Whatever the base voltage there, that base voltage we are selecting. Like this we can calculate the short circuit MVA. Students, is it okay? Understood, sir? Yes. Why EA2 not taking in negative sequence, sir? Yes, sir. I told, sir, very important concept I already discussed, sir. There is no EMF in negative sequence, sir. Only component is responsible for EMF is only positive sequence component, sir. Sir, see my previous video, sir. Previous video, see. You clearly understand. In detail concept of sequence components I discussed, sir. Total theory concept I given. What is the reasons also I given, sir. You please follow that one, sir. Yes, sir. Only positive sequence of current only responsible for induced EMF, sir. That zero sequence and negative sequence of induced EMFs are not responsible for that. Zero sequence and negative sequence currents are not responsible for production of induced EMFs, sir. Yes, sir. You please concentrate, sir. You see my previous video, sir. It's okay. YSK. Yes. Good evening, all of you, sir. The reason I told, sir, already. You please concentrate. See my previous video. Once again, I am telling, sir, only positive sequence of component is responsible for production of induced EMFs. Yes, sir. That's why in negative sequence and zero sequence, we can't consider any EMF, sir. You please concentrate, sir. Yes. I think the doubt is clear. Then what is the short circuit MVA 3VB into IF into A, sir? Like this, we can calculate short circuit MVAs. You please concentrate. Yeah, this is about LLG fault analysis with, but mainly here what points you remember, sir? That once again I am giving, sir, here which points mainly you concentrate. Therefore, in LLG fault, to solve the problems mainly in LLG fault without ZF, sir, without ZF, which points you remember, sir? Very, very important point is VA not equal to VA1 equal to VA2. Who are preparing for PSUs, Transco, Genco, Telugu state students. This condition so many times it is framed in competitive exams. Which are they giving some condition that indicates which fault. Like that it is asking, sir. Even ESE point of view also, sir. You please concentrate. VA not equal to VA1 equal to VA2 indicates which faults are LLG faults, sir. LLG fault without ZF. Then this is equal to how much, sir? VA by 3. This is equal to VA by 3, sir. Okay, that condition. One more condition, sir. By giving these conditions also it is asking in identify the type of fault, sir. Which faults are they giving? IA not, sir. IA1, sir. IA2 it is giving in the problem, sir. And it is asking identify the fault it is asking, sir. Add all those currents, sir. If it is 0, sir, this is LLG fault, sir. If IA0 plus IA1 plus IA2 equal to 0, that indicate the LLG faults. Understood, sir? Then third one is, what is IF, sir? What is IF, sir? 3IA0, sir. 3IA0. These points main important, sir. IF is. What is IA0 formula that I already given, sir? You please note down that previous slide I given. What is IA1 already you know, sir. What is IA2 also you already know, sir. All these you know. You remember these formulas along with these conditions. Solving of the problems is very easy. What the short circuit MVA, sir? What the short circuit MVA students, sir? Yes, 3 into VB into IF actual, sir. Actual fault current, sir. Actual in the sense, normally kiloamperes. That is with rating, sir. Kiloamperes or amperes, whatever you are getting. Not in per unit, sir. Not in per unit. Okay, actual quantities. You are representing in terms of actual quantity. Yes, sir. Okay, students. Then you concentrate LLG fault with ZF, sir. If ZF is considered, what are the conditions? Once you can write the conditions, analysis becomes very simple, sir. Once you can write the conditions, analysis becomes very simple, sir. Yes, students, concentrate. This is LLG fault analysis with ZF, sir. With ZF. With ZF. That is with ZF not equal to 0. We are considering the some fault impedance also. We are considering the some fault impedance also. Please concentrate. With ZF is not equal to 0. Yes, sir. Same conditions. Already pre-fault conditions I already written, sir. No need to write again. This is IA, sir. This is VA. Please, students, what the condition is changing if ZF is connected? Please, sir. You concentrate heart of the concept. Once you know the heart of the concept, remaining you do by your own. Okay? Yes, this is IA, sir. This is IB, sir. And this is IC, sir. IC current, sir. Now, let assume that there is a fault between this L and B, sir. And this is the grounded fault, sir. Line to line grounded fault, sir. And I am assuming that some fault impedance, sir. ZF. ZF also I am assuming, sir. The fault impedance is ZF, sir. Now it is grounded, sir. Now what happening here? If you connect the ZF, what is the observation, sir? Please concentrate, sir. This is IBIC, sir. This voltage is VB, sir. And this voltage is VC, sir. This ZN, sir. The neutral current is IN, sir. Yes. Yes, sir. This is under fault conditions, sir. This is under fault conditions. Now remaining this, this is VA. This excitation EMF is responsible only positive sequence component that you concentrate, sir. Okay. Now I am writing this during fault. Directly I am writing during fault, sir. Free fault condition already you know, sir. Free fault condition already you know. I am writing during fault. The first condition whatever I written, that is the free fault only. During fault, sir. Fault is not at A phase, sir. It is not at A line, sir. That's why IA is 0, sir. Why, sir? IA 0, sir. It's a no load, sir. IA is 0. It's a no load, sir. But VA is not equal to 0, sir. VA is not equal to 0, sir. Now, tell me, sir. This is IF, sir. This current is IF, sir. That is the fault current, sir. I am writing the conditions. I am writing the conditions, sir. Yes, sir. Under with ZF, sir. If it is grounded through ZF, fault impedance, where ZF is the fault impedance. You please. ZF is the fault impedance. It is the fault impedance, sir. Where ZF is the fault impedance, sir. Yes, sir. Now tell the students, please concentrate. Same. Here, which is the entering current, sir? IB, sir. Which is the entering current, sir? IC, sir. At this node, apply KCL, sir. IB plus IC equal to IF, sir. Leaving current, sir. You please concentrate. That's why one more observation is IB plus IC equal to IF, sir. Up to this, whatever I discussed without ZF, with ZF, both are same, sir. But now here changing. Yes, students. In the previous case, what I told, what is at this node, sir? VB. What is at this node, sir? VC. VC. But this is VB and VC is at same node, sir. But this is which drops, sir? IF into ZF, sir. Understood? In the previous case, VB equal to VC equal to 0, sir. But here it's not 0, sir. There is some drop is there in this branch. See, you please concentrate. This previous case I given like this, sir. This is VB, sir. This is VC, sir. Because it is connected to ground potential, sir. VB equal to VC equal to 0, sir. Now what I am explaining here, this is VB, this is VC, this is VB, this is VC, but there is some drop, sir. This is not 0 potential, this is the drop, sir. What is the drop, sir? IF into ZF. That's why VB equal to VC equal to IF into ZF. Over. Okay, this condition only teaching. This condition only changes. You please concentrate. Clear, students? Clear? You please concentrate. Now, I want to calculate symmetrical component of voltage. Symmetrical component of voltages. Symmetrical. Applying this condition. Same procedure I am following. Symmetrical component of voltages. Yes, sir. Symmetrical component of voltage. Yes, first I want to calculate VA naught, sir. What is VA naught, sir? 1 by 3 into VA plus VB plus VC, sir. Then what is VA naught equal to, sir? 1 by 3 into, I am replacing VC equal to VB, sir. What you can get? VA plus, I am replacing VC equal to VB, sir. What you can get? VA plus 2VB, sir. Is okay. Next. This is VA naught calculation, sir. This is VA naught calculation. Students, please concentrate. Now I want to calculate VA1, sir. Yes, this already conditions, you know. These conditions already, you know. I want to calculate VA1, sir. VA1 equal to 1 by 3. 1 by 3. VA plus alpha VA plus alpha VB, sir. This alpha VB. Yes, sir. Alpha VB plus alpha square VC, sir. You substitute that condition, sir. What is VA1? VA1 equal to 1 by 3. VA plus. I am replacing VC by VB. Because VC equal to VB, sir. These two I am taking. VC equal to VB. Take VB is common, sir. 1 plus alpha square, sir. What is 1 plus This is alpha plus alpha square, sir. What is alpha plus alpha square, sir? Minus 1, sir. Then what is VA1, sir? 1 by 3 VA minus VB, sir. VA minus VB. This is the calculation of VA1. Next, I am calculating VA2, sir. I am calculating VA2. You please concentrate, students. I am calculating VA2. Yes, sir. I am calculating VA2. Now, what is VA2, students? VA2 equal to 1 by 3 VA plus alpha square VB plus alpha BC. Then you replace VC by VB, sir. Replace VC by VB. 1 by 3 VA plus, take VB is common, sir. Alpha square plus alpha you can get. Yes, if alpha square plus alpha is how much, sir? Minus 1, sir. What is VA2, sir? 1 by 3 VA minus VB. Yes, sir. What is observation, sir? Yes, with ZF case, which voltages are equal, sir? VA1 and VA2 is equal. What is VA1, sir? 1 by 3 VA minus VB. What is VA2, sir? 1 by 3 VA minus VB, sir. Yes, sir. This and this is equal. This and this is equal. That is the observation for with ZF case. With ZF case, the observation is VA1 equal to VA2. But is not VA not equal to VA1 equal to VA2, sir. Here only VA1 equal to VA2. Students, please concentrate. With ZF and without ZF case. Clear, sir? Then what is VA1 equal to VA2, sir? VA1 equal to VA2. You please concentrate. Then how we can relate VA not here? How we can relate? Okay. These two, okay, sir. How we can relate VA not with VA1 or VA2? How we can relate? By knowing that relation only we can draw the sequence network. Because there is a zero sequence network also there. But I want to that network also. How we can connect that network means I want to know what is the relation of this VA naught with respect to VA1 or VA2. By knowing that relation only, I will draw the network. Total sequence network, sir. Then how to find that one, sir? You know this one, sir. You please concentrate, students. What is VB, sir? VB equal to IF into ZF, sir. Can you accept, sir? VB equal to, yes, sir. VB equal to VC equal to IF into ZF means VB equal to IF into ZF. Yes, sir. These conditions, sir, I am writing. VB equal to VC equal to IF into ZF means VB equal to IF into ZF that I am taking. Yes. What is VB formula, sir? What is VB formula? VA naught plus alpha square VA1 plus alpha VA2, sir. IF into, here I want to write some relation. That's why I am doing this analysis, sir. What is VA2 equal to, sir? VA2 equal to VA1, sir. Then VA naught plus alpha square VA1 plus VA2 equal to VA1, sir. Alpha VA1 that is equal to IF into ZF, sir. Then shall you write like this, sir? VA naught. Then take VA1 is common, sir. VA1 is common. Alpha square plus alpha, sir. That equal to IF into ZF, sir. Yes, sir. What is VA naught minus VA1 is equal to, what is IF, sir? This IF is, you calculated, sir. Already calculated. That IF equal to 3 IA naught into ZF. This IF already in the first case, you know, sir. IF equal to 3 IFZ. Where IF is how much, sir? 3 IA naught. This already you know. Fault current is 3 IA naught, sir. That VA naught minus VA1 equal to 3 IA naught into ZF. Then from this, what is VA naught, sir? VA plus 3 IA naught ZF. This is the relation for VA naught in terms of, but VA1 equal to VA2. Then VA naught and VA2 relation, you know. VA naught and VA1 relation also, you know, sir. By knowing this one, that means what the relations are. One relation is VA naught equal, sorry, VA1 equal to VA2, sir. But the another relations are VA naught equal to VA1 plus then 3 IA naught into ZF, sir. By knowing this one, now you draw the sequence network. Now you draw the sequence network. Is okay, sir? Okay. By knowing this one, now I am drawing the sequence network. You please, students, concentrate. Then how to draw the sequence network? Yes, sir. This already you know. Again, no need to write this one. You please concentrate. Yes, sir. This IF into ZF. What is IF here? IF equal to 3IA naught. That you already know, sir, in the first case. Now, I am drawing the network. Yes. First, I am drawing the positive sequence network. This plus minus EA1. Please concentrate. Okay. Next, I am drawing negative sequence network. Negative sequence net. This is Z2. This is Z1. Next, I am drawing zero sequence network. Zero sequence network. That impedance is there 3Zn. Okay. Okay, sir. Next. This is which currents are? IA1, sir. What these currents are? IA2, sir. What is these currents are? IA0, sir. This IA0. All these connected at same point because it's a parallel connections. Parallel connection. But here there is one relation must be satisfied. This relation must be like that. By satisfying this relation only you can connect, sir. VA0 equal to VA1 plus 3IA0 into Z. For that what I can do means I will connect one 3ZF here. 3ZF. It's a 3ZF, sir. 3ZF. This is which currents are IA0. Yes, sir. Remaining is okay. Yeah, this is the extra we are getting. This VA0 plus 3ZF. This is VA0. If you apply KVL in this case, this VA0 plus 3IA0 into Z. VA1. This is VA0 equal to VA1 plus 3IA0 into ZF or VA2 plus 3IA0 into ZF. Any one you write. This extra what you are getting, sir? 3ZF here. Sir, it's only ZF, sir. Why you taken 3ZF, sir? Sir, when I take 3IA0, this KCL will not be satisfied here, sir. That's why I taken 3ZF. This concept already given. Wherever 3IA0 is there, instead of ZF, you take 3ZF and you take the IA0. What is this current, sir? IA1. What these currents are? IA2. Okay, this is which one, sir? VA1. Clear, sir? Okay, this about what, how to draw that. Extra what we are getting, sir? Here 3ZF we are. 3 times of ZF. That is impedance we are getting. To satisfy this relation. If you want, apply the KVL, we can get this relation. Yes, sir? Is okay? Then analyze this network, sir. You know, already I given in the first case. Follow that procedure. Find the IA1, sir. Find the IA2, sir. Find the IA0, sir. How to analyze this network, sir? IA1 equal to EA1 by this Z1 plus this Z2 under Z0 plus 3Zn plus ZF. 3Zf. Z0 plus, sir. This is Z0, sir. Z0 plus 3Zn plus 3ZF is in parallel. These two networks are parallel. This comes in series. Extra which is added, sir. 3ZF it is added. Understood? I am writing EA1 by yes Z1 plus yes EA1 by Z1 plus this Z0. This total is Z0 equivalent, sir. Z0 equivalent. That is Z2 in parallel with Z0 equivalent plus 3ZF. 3ZF. Z2 in parallel with Z0 equivalent plus 3ZF. Then you write IA2 and IA0, sir. You find this one. I am giving for you. This you find. Apply which one, sir? Which one you apply? Current divider rule. In the previous case I given, sir. Same. But extra what you are getting? These 3ZF you take in series with Z0 equivalent, sir. That is the only case. You take 3ZF is this total impedance, sir. Now this total impedance, sir. What is this total impedance, sir? Z0 equivalent plus 3ZF, sir. Extra adding. But the 3ZF is added to this one, sir. Not for Z2, sir. But this total combination comes in parallel with Z2, sir. Is okay, students? Clear? Once you know the IA1 and IA2 and IA0, what is IF, sir? IF equal to 3IA0 fault current. IF equal to 3 IA naught. Yes, once you know the IF equal to 3 IA naught, sir. Once you know the IF equal to 3 IA naught, 3 IA naught, IF equal to 3 IA naught. Once the fault current equal to 3 IA naught, sir. What is the short circuit MVA, sir? Then what is IF actual, sir? IF actual equal to, if fault current is calculated in per unit, if fault current is calculated in per unit, this is 3 IF. If IF is in per unit, then what is IF actual, sir? IF per unit into IB. Then what is the short circuit MVA, sir? Short circuit MVA equal to, this is 3 into VB into IF actual. Like this you calculate. Yes, sir. One more observation I am giving, sir. Sometimes, sir, the networks are drawn like this, sir. Just by giving, why? Because in competitive exam, just they giving the box like this. If boxes also given, no problem, sir. Yes, that's why I'm drawn. Sequence network can also be drawn like this. Okay, sir. I'm taking either positive. Here you take positive. This is the negative sequence network. This is the zero sequence network. Okay, positive sequence, negative sequence, zero sequence. And this is, yes, sir. Yes, this current is IA1. This current is IA2. This current is IA0. This I am drawing without ZF case. Without ZF case. If you draw like this, if you want to draw with ZF means, then I am drawing the with ZF. Sir. You can add here how much impedance, sir? 3 ZF. You can add 3 ZF. Okay. Then this, sir. See this one. Similar terminals join together. Similar terminals. It's very simple, sir. I am adding this one. You please concentrate. See, if box like this boxes also you can draw, sir. No problem. But similar terminals are joined together. This one, sir. All these similar terminals. But here 3 ZF. These similar terminals are joined together. This terminal and this terminal is same. And these similar terminals. Please don't confuse if the figure is given like this. That's why students they are confused. If you are confusing with these boxes means, that's why once again I am explaining, sir. This is which one, sir? 3 ZF. Similar terminals, sir. This terminal is same. This terminal. It becomes which connection? Parallel connection. If boxes also given, no need to confusion. Sir is told only by giving windings, by giving that boxes is not, sir is not told like that, no need to think, sir. Point to remember, similar terminals are joined. Dissimilar terminals are joined, that is the series connection. Understood, sir? Is okay. This is the parallel connection. Without ZF means remove this one, short this one. That is without ZF case. This is which ones are positive sequence. This is which ones are negative. This is which ones are zero sequence. Clear, sir? This is IA1, sir. This is IA2, sir. This is IA0, sir. Yes, sir. All these. Then this is the similar terminals. Sorry, similar terminals are joined. Is okay, sir? If the boxes are given like this. Yes, sir. This is about what exactly? LLG fault analysis. Line to ground faults. Okay, this mainly which analysis are unsymmetrical faults. LG fault I given, LL fault is given, LLG fault is given. Next, two main important faults that I want to discuss, sir. One is triple L fault, triple LG fault. Those are also short circuit faults, but it is a symmetrical fault. Why? Even though system is subjected to fault, system remain in balanced condition. That's why those faults are taken as a symmetrical. Yes, sir. Students, is it okay? Understood what the concept I explained? You please concentrate. Yes, students, follow me on Unacademy using this link for more updates about my videos. For more updates about my videos. This is our Unacademy GATE Telugu Telegram channel. Whatever the concepts we are explaining every day, the total concepts we are uploading as a PDF material for your reference purpose. students. These are India's #1 study channels. GATE Electrical, Unacademy GATE Mechanical, that is a Creatics GATE Electrical, EC and Instrumentation students. Unacademy GATE Mechanical Engineering, Unacademy GATE Civil Engineering, Unacademy GATE Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Electrical Junction, Engineering Padashala, GS Terminal, RRB and SSC. These are India's #1 study channels. Please subscribe all these channels for more updates. Okay students, thank you. We'll meet in the tomorrow session.